Module 8, Stoichiometry. Using chemical equations when the limiting reactant is identified. Just like the building block house example I used in an earlier section, when you know the required relationship to make a product like a house, but are given a limited number of one of the reactants, that limited number dictates how much product you can make. Stoichiometry is helpful when we need to figure out the amount of products created when there is a limiting reactant. Let's say a chemist is wanting to produce silver chloride, AgCl, and he can do it with this reaction. Ag2CO3, or silver carbonate solid, plus 2HCl, or hydrogen chloride aqueous, produces 2AgCl, or silver chloride solid, plus H2O liquid, plus CO2 gas. If you think about it, silver is very expensive to work with, so it is important to use the precise amount necessary to make the desired amount of silver chloride without having any silver carbonate left over. In contrast, HCl is very inexpensive, so it might be a good idea to use excess HCl, even if he has leftovers and has to throw it away. He definitely doesn't want to throw away extra silver carbonate. Now, when we have the situation where we use lots of extra reactant to make sure the other reactant is the limiting reactant, we say we are adding excess reactant. You see, by having lots and lots of one substance, you are forcing the other substance to limit how much of the products you produce. So in this example, the chemist wants to make sure he uses all the silver carbonate. To make it the limiting reactant, he needs to add excess HCl. When we know that silver carbonate is a limiting reactant, we can use its number of moles to calculate the number of moles of each one of the products. Looking at the equation more closely, if a chemist had 1 mole of silver carbonate, he would want to use more than 2 moles of hydrogen chloride to make sure all the silver carbonate would be used up. That makes sure the silver carbonate is a limiting reactant. Then the entire mole of silver carbonate would be used, and the 2 moles of silver chloride, 1 mole of water, and 1 mole of carbon dioxide would be made, plus some leftover hydrogen chloride. Let's look at a sample problem together. Some ores contain a small amount of precious metals that are in compounds with many other elements. For example, one common ore found on Earth is KAgC2N2, or potassium silver cyanide. Since silver, Ag, is a precious metal, it is useful to be able to extract silver from this ore. The following reaction accomplishes this task. 2KAgC2N2 aqueous plus zinc solid produces 2 silver solid plus ZnC2N2 aqueous, or zinc cyanide, plus 2KCN aqueous, or potassium cyanide. If a chemist adds 5.61 moles of potassium silver cyanide to excess zinc, how much pure silver, Ag, can be made? Okay, we have excess zinc in this chemical reaction. That means that potassium silver cyanide is the limiting reactant. We know that the limiting reactant determines the amount of all the products in a reaction. We're told how much potassium silver cyanide we are using, and we're asked to figure out how much pure silver is made. We just need to figure out the relationship between potassium silver cyanide and pure silver. Then we can take that relationship and do a conversion. So the chemical reaction tells us that 2 moles of potassium silver cyanide equals 2 moles of silver. Now we can convert. What do we have? 5.61 moles of potassium silver cyanide. Put it over 1. What's the relationship between that molecule and silver? 2 moles of it equals 2 moles of silver. Set that relationship up as a fraction so that moles of potassium silver cyanide cancel. Multiply through to get 5.61 moles of silver will be produced. So as long as we know what the limiting reactant is, we can use its amount to set up a relationship between it and any of the products to determine how much of each product is produced. Stoichiometry is a funny sounding name, but get used to it. It's a wonderful method of using balanced chemical equations to determine how much material we either are producing or starting with when we are given a specific amount of one of the substances in a chemical equation. You see, in all of the problems we've gone over up to now, we're just using the relationship between 2 substances within the chemical equation. Then we can utilize that relationship to convert a given amount to find an unknown amount. Stoichiometry takes the numbers in front of the substances in a chemical equation and helps us get that conversion relationship we need. In fact, these numbers are given a specific name, stoichiometric coefficients. They help us to convert the number of moles of one substance to moles of another substance within the same balanced chemical equation.